Students, let us learn further part of our geometrical construction lesson. So the further part is conditional statement. Now, like the name says, conditional statement means a statement in which you will find a condition which has been put. That kind of statement is called as conditional statement. So if that statement has if and then in them, then you can say that that statement is a conditional statement. So I'll give you one simple basic example. So if you don't wear ID cards in school, then you will have to pay fine of 100 rupees. So there is condition over here. What is that condition? If you don't wear ID cards, then then part which is there, that is the condition which sister principal has put on you. Then you have to pay 100 rupees fine. That is the condition. So when there is if and then in the statement, that kind of statement is called as conditional statement. So the if part which is there in that statement, that is called as antecedent, and then part which is there, that is called as consequent. So if you don't wear ID card in your school, so that part, if part is antecedent, then you will have to pay 100 rupees fine. So that part will become consequent. So why it is called as consequent? Because if you don't wear ID card, then what will be the consequence? Then you will have to pay 100 rupees fine. So because it is a consequence that you have to pay 100 rupees fine, that part is called as consequent. So these two words you have to keep in your mind. If part of the statement which is there, the big part, that is called as antecedent, and then part of the statement is called as consequent. I will give you, this was the basic example. So we have to learn about the example which suits geometry. Okay, so the coming example is, consider the statement, the diagonals of the rhombus. So the diagonals of the rhombus are perpendicular bisectors of each other. So what do we understand from this statement? If the figure is rhombus, okay, it is clearly mentioned, if the figure is rhombus, then its diagonals which are there, they are perpendicular bisectors of each other. If the figure is triangle, is this statement possible? Can we draw diagonal and will they be perpendicular bisectors of each other? No. So it is clearly mentioned, if the figure is rhombus, then only its diagonals will be perpendicular bisectors of each other. So of this statement, if we have to write conditional statement, how do we write down? Pay attention. So the conditional statement will be, if the given quadrilateral is a rhombus, okay, so in statement it is clearly mentioned, only if it is the quadrilateral, if it is rhombus, then, so you can see here, if part is what? If the quadrilateral is rhombus, then what happens? Its diagonals are perpendicular bisectors of each other. So in exams you will be given such kind of statement and you have to convert into if and then statement. Okay, so this is how you convert. Moving forward, if the antecedent and consequent in a given conditional statement are interchanged, then the resulting statement is called as the converse of the statement. So if we do ulta, if the if part of the statement, if we put it in then part, and then part if it comes in if part, then if we do interchange of the conditional statement, then the resulting statement is called as converse. Converse means ulta of the given statement. If the conditional statement is true, its consequent is not necessarily, its converse is not necessarily true. So I'll give you one conditional statement here and then we will write its converse and let us see whether its converse is also true. So the conditional statement, I'll take one basic example. Let us take example of coronavirus. So I'll give you the conditional statement here. If you go out of your house, then coronavirus will attack you. Okay, so what is the conditional statement? First, I have given you the example of conditional statement. If you go out of your house, then the coronavirus will attack you. Now, let us write its converse. So, what will be its converse? If the coronavirus attacks you, then you have to go out of your house. So, is the converse true? So, if the coronavirus has attacked you, Do you have to go out of your house or you have to stay inside your house? You have to stay inside your house and take rest. You don't have to spread. So the conditional statement was true. If you get out of your house, if you go on a crowded place, then coronavirus is going to attack you. But what was its converse? If the coronavirus attacks you, then you have to go out of your house. So the converse was not true. Okay. So if the conditional statement is true, its converse is not necessarily true. Sometimes it can be true, but not necessarily it is supposed to be true. Okay. So we are going to see two examples of mathematics or geometry based on conditional statements and its converse. So the first example is, here the conditional statement is given. Pay attention to the green part and the pink part. If a quadrilateral is a rhombus, so what is this green part? That is the antecedent. That is if part, right? Then its diagonals are perpendicular bisectors of each other. So this then part is colored in pink color. You can see it has pink color. So that is consequent part. So that is the given conditional statement. What will be its converse? Let us see. Its converse will be, so this then part, pink part which is there, it will come to if, and this green part will go in then part. We interchange, right? For converse we interchange. So let us see. If the diagonals of the quadrilateral are perpendicular bisectors of each other, then it is a rhombus. So you can see here, then part which was there, its diagonals are perpendicular to each other, that we have written for if part. If the diagonals of the quadrilateral are perpendicular bisectors of each other, then it is a rhombus, right? If part we have written in a then part. So this converse which is there, this was the conditional statement and its converse is true. For this example it is true. If you draw diagonal and if of diagonals in a quadrilateral, and if they are perpendicular bisectors of each other, then the quadrilateral is a rhombus. So the converse is true here. Let us see next example. In this example, conditional statement and converse both are true. Now let us see second example. Here the conditional statement is, if a number is a prime number. Okay, if part is again put in green. If a number is prime number, then it is even or odd. Okay, what is a prime number? Prime number is a number which is divisible by 1 and itself. Okay, so 2 is a prime number. 2 comes in 2's table and 1 table. 3 is also a prime number. 3 also comes in 3's table and 1 table. 4 which is there, it is not a prime number. Why? Because 4 comes in which table? Which table? It comes in 1's table. 1 4s are 4. It comes in itself. 4 1s are 4. And it also comes in 2's table. 2 2s are 4. Right? So 4 is not a prime number. So we now understood what is a prime number. So here the statement is given as, if the number is a prime number, then it is even or odd. Now you must be knowing what is even and odd. 1, 3, then 5, then 7. All these are odd numbers. And even numbers are 2, 4, 6, 8. All these are even numbers. So a prime number, if it is a prime number, then it can be even or odd. So 2, it is even and it is prime number also. And 3 which is there, it is prime number as well as it is odd. So this statement is true, conditional statement. Let us see what is the converse. If the number is even or odd, now then part will come here, pink part will come here. If the given number is even or odd, then it is a prime number. So here the converse is not true. Okay, so if the given number is even or odd, so I can take any even number. If I take here 4, then is it that 4 is an even number? But then is it a prime number? No, it is not a prime number. It is composite number because 4 comes in 2's table also. So it is not an even number. So here the converse is false. It is not true. So I have given one example where conditional statement and its converse was true. But here in second example, the conditional statement is true, But if we write its converse, it is not true, it is false. Hope you all have understood these two examples about conditional statement and its converse. Now let us learn about proofs. Now what is a proof? So we have studied different properties about angles, triangles, quadrilateral in your previous standards, right? So for example, the simple property of square can be square has all equal sides, right? Rectangle, the opposite sides are equal. So these are properties of square and rectangle. So if anybody asks you how will you define square, then what is its property? All the sides of square have equal length. They are equal. And if somebody asks you what is a rectangle, then what you will say? The opposite sides of rectangle are equal. So these two are properties of square and rectangle. So all these properties which were there, they were invented many years before Christian era. So this Greek mathematician which was there, Euclid, his name was Euclid, he gathered all the knowledge of geometry, all these properties which were invented, and then he put those geometrical statements. So these were the geometrical statements, all these properties which were there, they were the geometrical statements. He told, or he called this geometrical statement as postulate, and on basis of this postulate some more properties can be proved logically. Why he called postulate? Because if we prove this postulate logically, then we call them as theorems. Okay, somebody like other scientists which were there, they had just given this properties in the form of statements, but nobody had proved, right? So some properties which were there, we could actually prove. So how do we prove these statements? We measure the sides of a square by using scale. So these are called as proofs. So when we write down the proofs, you must have studied Pythagoras theorem in previous standard. You must have studied many postulates. So to prove those postulates, you have to write down many statements, and finally you get the statement and you prove the postulate, right? So what Euclid did was, there were many properties and the statements which were given, but he called those statements as postulates, and then those postulates can be proved logically by giving statements or by solving mathematically. We could solve mathematically or logically, and those properties which are proved logically are called as theorems. Okay, so some postulates which are of Euclid's postulates, they are called as, are given below. There are infinite lines passing through a point. So this was one postulate which he was able to prove by giving many statements, and then proof was given. So this postulate is also called as theorem, where he, with many statements, he is able to prove this statement. There is one and only one line passing through two points. So this was also a postulate which was proved by Euclid. Third postulate was, a circle of given radius can be drawn taking any point as its center. So this was also proved by Euclid. All right angles are congruent with each other. This was also proved by Euclid by solving. So the postulate which can be proved by solving logically are called as theorems. And inside theorems, so let us see, a property is supposed to be true if it can be proved logically. Then it is called as theorem. So any property which were there, Euclid called them postulate, and if we prove it logically by giving appropriate statement, then it is called as a theorem. A logical argument made to prove a theorem is called as proof. Okay, so what is proof? Even in court we call that if you have not made any mistake, you have to show any proof, right? So in theorem also, a statement is given, and to prove that statement you have to give proof. You have to give mathematical calculation, or you have to give logical statements, and by giving logical statements as well as calculation, you prove that statement. So that logical argument made to prove a theorem or a postulate or a property is called as proof. We have to prove that conditional statement is true. So whenever conditional statement is given, you have to prove that conditional statement whether it is true or not. So that is called as theorem. So there is a conditional statement, if and then. Always whenever you hear conditional statement, always in that conditional statement there is given part, and that given part is if part. Like I told you, conditional statement as if and then part. So if part which is there, it is called as given part. That data we already have. And then part which is called which is there, that is called as the part to be proved. So then part of the statement, that part we have to always prove by giving logical statements or proper proof. Okay, so the given part which is if part is called as antecedent, which all already know, and the part to be proved, that is then wala part, is called as consequent. So this was about conditional statement. So in near future, whenever you have to prove any statement of theorem or any postulate of theorem, if that is a conditional statement, then always remember the given part, if part of the statement is always a given part. So that is a data which you have, that part is called as antecedent, and the part you have to prove, that is the then wala part in the conditional statement, that is to be proved part, and that part is called as consequent. I hope till here you have understood very properly.